when you take notes, you need to put the section number. This is the second unit, and this is the second lesson. That's what 2 means. And we're going to multiply polynomials, and you need to put the date. Now, yesterday we multiplied polynomials, but the polynomials that we multiplied yesterday were binomial, back up, I said that wrong. This is a monomial times a monomial. The examples and the problems that we did yesterday were monomials times monomials. What we're going to start with today is a binomial times a binomial. We're going to multiply binomials. This is a fairly simple, but it is a binomial. Do you know when it's a binomial? See the two parts? And so we're going to multiply a binomial times another binomial. There are several different methods to do this. I teach this using the box method. Do you see a box? The box has 4 parts. A binomial times a binomial takes a 2 by 2 box. The first, I miscopied that. I changed your notes to x plus 7 and x plus 3. Because the x plus 7 goes at the top of the box. The x plus 3 goes on the side of the box. And this is a concept from geometry. This ties into geometry. I guess that's why I like this method, because I taught geometry for a long time. Do you know how to find the area of a rectangle? Length times width is the area of a rectangle. That's what I'm doing in this box method. I am finding the area of this rectangle right here. The length is x, and the width is x, and what's x times x? If it's x on this side, it's x on this side, so this next rectangle is x times 7. If it's x on the top, it's x on the bottom, so x times 3 is 3x. And the area of this one over here is 3 times 7 is positive 21. Another reason I like the box method is it keeps everything organized. If you're missing a number in the box, that means you haven't multiplied it together and you're missing something. And so it becomes very obvious by using the box problem. So what we learned yesterday is that we have to combine like terms. In the box, do you see some like terms? Are these two like terms? And so we have an x squared, and these two are like terms, and then we have the 21. So when you multiply a binomial times a binomial, you often get a trinomial answer. When you write down the answer, it needs to be in standard form. Standard form means the x squared comes first, and then the x term, and then the constant number. That was so fun. We'll try again. So the first binomial is x minus 6. I make my box and I put the first one on top and the second one on the side. By the way, you're multiplying together. The order doesn't matter. You could put either one on top and either one on the side. But I always do it the same way so I don't confuse myself. X times x is x squared. x times negative 6, negative 8 times x. 8 times 6 is 48. Negative times negative makes a positive. Do you understand where the numbers inside of the box came from? Because if I lose you there, then you are going to be lost forever. And so, it looks like everybody understands that. Then you look at the box, and you combine like terms. You write them down in order with the x squared first, and then the x, and then the constant. A negative 8 plus a negative 16 gives you a negative 14. Was there a question? I may have said it, I think I said it wrong, but I wrote it correctly. I do that a lot. What I wrote, not what I said. X minus 4x plus 12. Now, one of the other reasons I like the box problem is you don't have to learn one method for binomials and one method for trinomials and one method for polynomials that are bigger than that. The box method works for everything. If you have a bigger problem, all you need is a bigger box. But you do it the same way. X minus 4 goes on the top. X plus 12 goes on the side. Multiply x times x. Multiply negative 4 times x. Multiply 12 times x. 12 times 4 is 48. Positive times a negative makes that a negative 48. Combine like terms. X squared is that one. 12 plus a negative 4. And then we have a 48. Your answer should be written in that form where the squared comes first and then the x and then the constant number. Do these kind of problems seem pretty easy? I will mention you may have been taught another way. There are other methods. If you know another method, you can use it. But I started teaching it this way because it seemed less confusing to my students. X times x is x squared. X times 9 and 5 times x. That would be negative 5 times x. 5 times 9 is 45. Positive times a negative is negative. Was there a question?
Does it matter if you put the negative 5 where the positive 9?
It doesn't matter about the order. You would get the same answer. You could put the x minus 5 on top and the x plus 9 on the bottom. What matters is what kind of 5 is this. So when you write it down, make sure you write down that it's a negative 5 so you can get the signs correct. So you get the same answer if you haven't made a sign mistake. The x is squared. 9 plus negative 5 and minus 45. Now, binomial by binomial, there is a pattern. See the pattern. So, when we a 9 times a 5, this final answer, this final part, is always these two numbers multiplied together. How do you get this middle term? Every single time. We're going to come back to that pattern in a minute. I'll let you think about that for a minute. The pattern does not apply to a problem like this that is a little bit more complicated. Yes, this is our next example. This is a monomial times a trinomial. I could use a box problem for this, and it would just have a 1 by 3 box. But this is just a monomial, so this means that I need to distribute. This is just a distribute problem. By the way, the first 4 examples were also distribute problems. They were double distribute problems, and that's why it's easier to help us use a box problem. So to distribute, I'm going to multiply the 3x times the x squared. I'm going to do this out step by step. And the 3x gets multiplied by the 2x. And it's negative because of that negative sign right there. And the 3x gets multiplied by the 4. That's what it means. That's what those arrows mean, right? Do you know what we get when you multiply 3x times x squared? Do you know that x squared is the same as x times x? So this would be x times x times x. Three times 2 is 6, and there's the negative sign right there. X times x is x squared. The 3 times the 4 is a 12, and then there's an x. And then we step it up a little bit more. This is a binomial times a binomial, but why is this a little bit harder than the first 4? Is this just a simple x here? This just has a 3x. This has a 2x. It really is about the same difficulty if you are using the box problem. It's a binomial times a binomial, so I need a 2 by 2 box. And I always put the first one on the top and the second one here. If I always do it the same way, I'm less likely to make a mistake. But it doesn't really matter whether you put the 3x minus 4 here or here. They could switch places because you're going to multiply. And 3 times 2 is going to be 6x squared. And 2 times 4 is negative 8, and it has an x from that one right there. 3 times 5 is 15, and it has an x. 5 times 4 is 20. Positive times negative is a negative. And then combine like terms. 6x squared, positive 15, negative 8. And then we step it up again. A binomial times a binomial times another binomial. Now, I have 3 binomials multiplied together. I can't multiply all 3 together at the same time. You've got to pick 2. It really doesn't matter which 2. So, anybody want to pick? You might, don't have to, but you might pick those 2 to start with because those are simpler because the x doesn't have a number in front of it. The x does not have a coefficient other than 1. You don't have to start there, but you do have to pick 2 to start with. So I picked these two to start with, and I will multiply those together. X times x is x squared, minus 5x, 7x. 7 times 5 is 35. Positive times negative is a negative. Combine like terms. These are like terms. And I'm going to write it right down here below. So this is x squared plus 2x minus 35. This trinomial, this is the answer to this part right here multiplied together. But I still have a 2x plus 6 that I hadn't multiplied yet. So here's part 2. Multiply 2 at a time. So I multiplied these two together. Now I need to take that answer and multiply it by this one. This is a binomial times a trinomial. When you use the box, it's the same method, only a bigger box. I have a 2 by 3 box instead of a 2 by 2 box, because now I have to have room for a trinomial. And that's why I like the box method, because it works for all polynomials. It doesn't matter how big they are. 2x times an x squared gives me 2x to the third power. X squared times another x is x to the third power. This would be 6x squared. 2 times 2 would be 4x squared, because x times x is x squared. 2 times 6. 2 times 35, and that has a negative sign, and that has an x from that one right there. 6 times 35 is 210, and it's going to have a negative sign from that one right there. Now, this time, these are like terms, and these are like terms. This time I have 2 sets of like terms. So all I have to do is combine like terms in my box problem for the final answer. 4 plus 6 makes a 10x squared. Negative 70 plus 12 would be a negative 58x minus 210. Was it really more difficult? It just had more steps because I had a binomial times a binomial times a binomial. And you can only multiply 2 at a time. Multiply 2, get an answer, take that answer, and multiply it by the third one. Again, this has connections to geometry. Find the volume of a cube with a side of 3x minus 2. The side of the cube is this binomial. Now, first question, do we know what a cube is? A cube is like a 3-dimensional square. Do we know how to find volume? Do we know that volume is length times width times height for any kind of rectangular prism, any kind of box? But if it's a cube, the length and the width and the height are all the same. So to find the volume, we're going to need to multiply a 3x minus 2 for the length, and a 3x minus 2 for the width, and a 3x minus 2 for the height. If you have 3 binomials, you have to pick 2, multiply 2 together, get that answer, multiply it by the third one. This is a binomial times a binomial, so I need a 2 by 2 box. Three times 3 is 9x squared. 3 times 2 is 6. That'll be a negative, and it'll have an x from that term right there. 3 times 2 is 6, and it'll have a negative, and it'll have an x. Negative 2 times negative 2 is positive 4. This has like terms. So these two multiplied together are 9x squared minus 12x plus 4. That's the answer to these two. And we still have this height down here that we have to multiply by. When you multiply a trinomial times a binomial, all you need is a bigger box. Once again, it wouldn't have mattered if you made the box the other way. You could put the trinomial down this side and a binomial on top. That doesn't make any difference. You just need to get, and the purpose of the box is to make sure you don't forget any of the terms, to make sure you get everything multiplied together. So 9 times 3 is 27x times an x squared. 3 times 12 is a negative 36 with an x. 3 times 4 is 12, and that will have an x. 9 times 2 is 18. That'll be negative 18x squared. Negative 2 times negative 12 is positive 24 with an x. 2 times 4 is 8. Negative times positive would be a negative. These are like terms. These would be like terms if I had written them down correctly. This was x times x, so this needs to have a squared on this one. So my volume is 27x to the third power. When I combine that, both of these are negative, so that's negative 54x squared. These two combined would be 36x minus 8. Now, before we end our notes for today, I want to go back and ask you, did you see from the first 4 examples, I know 4 examples isn't a lot. I didn't think you'd want to sit there for me to do 50 examples. But did you see the binomial pattern? If I multiply this box problem you get x squared plus 9x plus 20. Looking at this example, your first 4 examples, what is the first term? X to the power of 2, x squared. Now, this pattern only applies if you have x with a coefficient of 1 and an exponent of 1. It only applies if you just have an x here. That means the coefficient is 1 and the exponent is 1. The reason this pattern is useful is that comes up a lot in the problems that we're going to be doing in the next several months, and maybe all the way for the rest of the year. What about the last term? How do you get the last term? This number right here, how did you get it? You multiplied the 4 and the 5. Look at the first 4 examples. How do you always get the last term? What about this middle term? How do you get the middle term? Did you see the pattern? So, if you want to use the pattern, you can use the pattern if you see the pattern and if you don't make any sign mistakes. If it helps you to keep everything organized, you can use the box problem. Once again, the pattern only applies when you have simple problems. So you will do assignment 2-2. That's the one that goes with these. Now today is Thursday, so normally it would be due on Monday, but we don't have school on Monday. So this will be due. Somebody have a calendar out? What's the date on that Wednesday? The 14th. You will be virtual students that day, but can you still turn in an assignment? Sure you can.